Hi, welcome to Mathematics with Tom. I am Tom, and today we are going to look at finding the null solution for a second order linear differential equation. So here's the problem that we're going to look at. We're going to solve ay double prime plus by prime plus cy equals 0, and you'll have, when you're solving a second order equation, you're going to have two initial conditions. So you'll have some initial condition y of 0 and y prime of 0, and we'll see how that works here shortly. Well, how do we solve this? Also, when we look at this, remember when we first looked at this, we said we had really the problem of ay double prime plus cy equals 0. And we described this for a being the mass and c being the stiffness of a frictionless environment in which a spring might move. Well, now it's only natural to have that by prime term. And the by prime is damping. So ay double prime is the mass, the effect of the mass. Cy is the effect of the spring itself. by prime is damping on the system. So let's try this. And that's exactly what we're going to do. We're going to try. I'm just going to write y. Well, it's really the null solution, but unless I said otherwise, we're just going to write y for simplicity. Y equals e the st. That's what we're going to start with. In the same way that E has solved our first order equations, let's see how it works in a second equation, for lack of a better place to start. So notice then we're going to need the second derivatives and first derivatives. So find y prime. Well, that's going to be s e to the st, and y double prime is going to be s squared e to the st. So as you might expect, let's just substitute these into the original problem. So substitute. Into original problem. Original problem. Okay, so let's try that. So now we have a, and y double prime, we said this is s squared e to the st plus b times y prime. Well, y prime we just found is s e to the st plus c times y, which we said is e to the st. And this is the null solution, so it equals 0. Notice that we have the exponential as a common factor. So let's factor this into as squared plus b times s plus c times e to the st equals 0. Oh, and notice this. Notice we know that e to the st is a non-zero function. So in other words, the real problem is just about figuring out when this polynomial as squared plus b times s plus c is 0. So let's do that. As squared plus b times s plus c equals 0. This is called the characteristic polynomial. Characteristic polynomial. And it's that right there. Now, but look at what it is. We've taken our second order differential equation, and now the solution lies somewhere in solving this. Well, this is just a quadratic. It's a second degree polynomial. We know how to solve this. s is our variable, so really this gives us the solution of s equals negative b plus or minus b squared minus 4ac, and we take the square root of those second two terms, divide all of that by 2 times a. That's our solution. And what we would do then is we say our null solution, notice it's going to have two solutions. One of those is s1 equals negative b plus the square root of b squared minus 4 times a times c over 2 times a. And our second solution, s2, is negative b minus square root b squared minus 4 times a times c all over 2 times a. And those are our solutions. So here's what we can do. Notice that there's two solutions. So normally we would have written, well, y null, or is y in this case, is some constant c1 times e to the s1 t. But now we have two of them, so we're going to write them as c2 e to the s2 t. And c1 and c2 can then be calculated based on the initial conditions that are provided. So there's one last thing that I'd like to show you. It's something maybe we take for granted, or maybe we've never done before. So I thought I would just bring this to your attention. What I wanted to do is let's take a look at this, the sum and the product of the solutions. So I'm going to go to a new page. I'm going to go to a new page. Notice this. Let's take S1 and add it to S2. All right. So we have negative b plus, we have this big square root of b squared minus 4ac over 2 times a plus, we have negative b plus, or minus, we already got the plus, so minus square root of b squared minus 4 times a times c, all of that over 2 times a. Oh, look at this. We already have a common denominator. Oh, the square roots, the b squared minus 4ac, we have a positive one, we have a negative one. Those are opposites, so those are going to cancel. So now all I have left is a minus b plus a minus b. This is a minus 2 times b over 2 times a, and this just reduces to negative b over a. Also, let's try the product. What happens if you take S1 times S2? Okay, well, let's see. So I have negative b plus the square root of b squared minus 4ac over 2a times, then we have negative b minus square root b squared minus 4ac over 2 times a. Now we get to distribute this. So when we do this, I'm going to start with the negative b in front. So I'm going to distribute. Here's the first step. So this is going to give me negative b times negative b. That's a b squared. And the second thing is I'm going to distribute out to the, like this, the green arrow. So this is going to be plus b times square root b squared minus 4ac. And then we're going to grab, or let's do a yellow one. So now I'm going to distribute the radical. So that's going to take me to here. So this is going to be a minus b times the square root of b squared minus 4ac. Oh, and then let's do this pretty pink. When I take the pink one, it's going to land right there. And now look, the radicals, they're going to cancel. And I have a plus and a minus, which is a negative. So this is going to be a minus b squared minus 4ac. And then in the denominator, 2a times 2a, that's 4a squared. Oh, look at this. So if you have this nice icy blue color, these middle terms, those are opposites. That's just 0. And then if I add, oh, look at this. I've got more zeros tucked into this problem. This pretty purple, here's a b squared minus a b squared. I'm left with plus 4ac. And there is your final answer. We have 4 plus 4ac over 4a squared. This is going to leave me with c over a. I hope that helps, and thanks for watching.